Hello and welcome to Lesson 3 in the Python Crash Course. The course was brought to you by Banana Chip Tech. My name is Sam and we are going to be talking about variables today. So to start off with, let's talk about what is a variable and why we use them in Python. Variables are ways that we can store information. And the way that I like to think of variables is like a jar where we can stuff stuff in and then take it out later. So if we give an example using food containers, for instance, we have our peanut butter jar where we have our peanut butter stored, and then we can take our peanut butter out and use it later on when we want to make our peanut butter and jelly sandwich. Similarly, we can have a pizza box, which is holding our pizza. We can eat a piece of pizza from our pizza box as well. So those are just some analogies of what a variable could look like if we were to imagine it as a food. It's very important that we distinguish between the types of variables when we talk about variables in Python. Now, Python itself doesn't force you to tell it what type of variable you're going to be storing, but it is important to know the type of variable that you are storing when you are using variables in Python in order to get the behavior that you expect. This will make a little bit more sense when we jump into our coding section, but I just want you to be aware that even though we don't have to explicitly tell Python what type of variable it is that we are creating, we do need to be cognizant of what is that type of data that we're storing. And so on that note, let's kind of dive into the different types of variables and what each of them do. And so once again, I want you to remember that the lessons that we're learning here in Python, while they're kind of focused towards Python, they are applicable to other programming languages as well. So a lot of these same variable types you'll see in other languages such as C++ or Java. So let's start off with what I like to consider the basic variable types. Basic variable types only contain a single piece of information. And these basic variable types are like our peanut butter, where it's just one monolithic peanut butter. The first type that we need to discuss is an int. Int stands for integer, and integers are basically whole numbers that don't have a decimal. They can be negative, they can be positive. As long as they don't have a decimal, they are considered an integer. So let's do some examples. We can say 1 is an integer, 2 is an integer, 5,000 is an integer, negative 5,000 is an integer, 0 is an integer. But what's not an integer is 1.3, 1.0 even, or 3.14. And these, when they have a decimal, are going to be considered floats. So again, the difference between integers and floats are the presence of the decimal or not. So the next kind of basic variable type that we can talk about is a Boolean. And so Boolean is just a fancy name for a true or false variable. So it'll either be true or it'll be false. And that is all a Boolean is. Pretty simple. Just don't get too confused by the name. Finally, we have a char or a character, which is just one single character. So think of it as if we type in A on our keyboard or B or C on our keyboard. Just a single character is considered a char. Now, the second types of variables that I like to discuss are what I like to call data structure variable types. And so if we go back to our food analogy, if basic variable types are like our peanut butter, our data structure variable types are like our pizza box, where within our pizza has multiple toppings and multiple foods on the pizza itself. So if we have a pepperoni pizza, we'll have bread, tomato sauce, cheese, and pepperoni. So those are 4 different foods compared to just a peanut butter like we had with our basic variable types. And so think of these as kind of collections of the basic variable types in a certain way. And this is not a canonical list. I think I got the majority of them here, and I got the important ones here. But recognize that there might be some other data structures that people create, such as like a ordered dictionary or a map. Map and dictionary in Python are pretty interchangeable, but in other programming languages, they use maps instead of dictionaries. And so again, these are just the overview of some of the more common ones. So the first one is a string, And so a string is pretty much just a sequence of text. There's no size restrictions, there's nothing else associated with a string other than just a line of text. And we'll do some examples with strings in our coding tutorial. I want you to take a minute here and think about, what do you think composes a string? What of the basic variable types that we just discussed compose strings? So I hope you thought about that, and the answer would be a character. So for instance, we have our single character like A or B, and if we put them together, we would get a string. The next data structure that we're going to discuss today is a list. Lists are basically a collection of different variables put together. Now, some key features of a list are that they are ordered and that they are mutable. They are ordered in the sense that the order that elements are inserted or are put in the list will remain the same order that they will be stored in the list. They are mutable in the sense that elements within the list can be changed. Now, lists themselves have no specification of what data type can go into it. So you can have a list of integers, a list of floats, a list of booleans, a list of integers, floats, and booleans, a list of characters, a list of strings, a list of tuples even, or even a list of lists. As long as you put them within the format of a list, they'll be considered a list. Now, a set, on the other hand, is similar to a list in that it holds a collection of elements, but it is different in the sense that it only holds unique elements, and it is unordered. Now, tuples are also similar to lists in the fact that they hold elements and that they are ordered, but they are different from lists in the sense that they are unmutable, so they cannot be changed. And finally, the last data structure we'll talk about is a dictionary. And dictionaries are key value pairs, which means you can use a key to find some other information that's associated with that key. So if we go back to our food example, let's say we have our spices, we have salt, pepper, garlic powder, red chili powder, whatever other spices you may use. We can, based on the label of our spices, so let's say we're looking for salt, we can match that salt to the container that is holding salt and then take the salt out from that salt container, out of our jar of spices. So in that sense, we don't have to go through every single spice in our jar of spices like we would have to in a list or a tuple. Rather, we can go directly to what we're looking for based on the key that we have. So let's start off with the basic data types. As you can see, I've already created a new PyCharm project called variables and added in my comments, as well as sectioned off a part for some basic variable types. So the first basic variable type that we're going to talk about is integers. And as we mentioned earlier, integers are just numbers without a decimal. So to create an integer, all we have to do is enter the name of the variable. So it's going to be whatever we want it to be. So I'm going to say my int for now, and we just set it to a number. Now, notice the way that this is structured. We have, on the left-hand side, we have the name of the variable, we have an equal sign, and we have the number that we're trying to store. So you have to read this left to right, where on the left side is the holding place or our variable, and the right side is whatever we're assigning to that variable. Now notice I can do my int2 equals 10, potato int equals 15, etc equals 20. And so it doesn't really matter what the name of the variable is, as long as you're consistent with how you use it. So I'm going to go ahead and print these out. So do my int2, potato int, and etc. And notice I didn't have to do any special changing or anything if I wanted to print it out to the screen. That's just because Python by default knows how to print out integers and all the other basic variables that we're going to be talking about shortly. So you can see here that we have it all printed out. Awesome. So next we're going to move on to floats. And so floats, again, if integers have no decimal points, floats do have a decimal point. So let's do an example of a float. So we'll say my float equals 3.14. Then we'll say my float 2 equals 5.62. And so those are two examples of floats. Now notice if I say my float 3 equals 3, when we print it out, look at the difference between the floats. My float 2, my float 3. And so notice how we have our decimals here in our bottom side, but this last one does not have a decimal. And in fact, it looks like an integer like we described earlier. And that's because we didn't set it in a way that represents a float. Python is going to treat it as an integer. So that goes to show you that whatever's on this left side here, it doesn't matter in determining the type of the variable. It's just the name. Think of it as just like a name or a label that you're using to refer to that variable. So if we want to change this to a float, we're just going to have to add a 0.0 at the end here. And notice after we do that, we have a 0.0. All right, sweet. So now let's move on to our booleans. So our booleans can only be true or false. So if we say bool1, we can say true, and bool2 equals false. Notice that PyCharm highlights them in a different color. That's how you know that these are actually booleans, boolean variable, or these are actually valid boolean variable responses. So the T in true is capitalized, the F in false is capitalized, but everything else is lowercase. So if I did true like this, notice that it doesn't highlight it in the same color because it's not what Python considers the Boolean variable true to be. So the next one we're going to do is we're going to do a character. So Python doesn't exactly treat characters separately as strings, so it really kind of loops them into strings. And we're going to be talking about strings next, so I'm just going to go ahead and include strings in this conversation. And we're going to also change this, so we'll start our data structure variable types. So a character, as I said earlier, is going to be one single character. So this would be a character. Now, Python, by default, doesn't treat single characters as characters, per se. It automatically defaults them to string. And if you remember from what we mentioned earlier, strings are part of the data structure variable types in the sense that they're composed of multiple other smaller variables together, right? Strings are a list of characters. And so to make a string, we're just adding multiple characters together. So that goes to show you that we can say this is a string. Notice it didn't matter how much spacing is in between there. And I'm going to go ahead and just print out my string. We've covered strings a little earlier in our input and output section. So now before we move on to the other data structure data types, I want to take a little bit of a minute here to talk about how we can use these different types when reading input into a program. So let's say we have our input function and we say, give me a number. And we'll set that equal to user number. If we go ahead and print user number, let's see what we get. So now input, now notice it's waiting for us to put in a number, so we put in 3, and it prints out 3 to the screen. Looks good, right? So now let's change this up so that, let's say we want to multiply the user's number by 100. Or let's just do 10. Now, notice what I did here. I set user's number equal to user's number multiplied by 10. And this is important because we're saying I want to perform this operation here on the right, user number multiplied by 10. But then after I do this operation, I want to save it back into user number. And then print user number out to the screen. So let's see what we get. So we got So instead of 300, which is what we would expect to get, we got 333333333. And so this is why I'm really trying to harp on the differences between variable types, is because understanding what type of variable you have in your program will help prevent errors like this. So whenever we have input, Python reads whatever text we put in into the program as a string, right? Because it just sees some text. It's like, I'm going to treat it as it is, and I'm going to give it to you as it is. I'm not going to do any predictive stuff on what I think it is. I'm just going to give you what the user has written in the console, basically. And so if we want to fix this and we want to say, hey, Python, I want you to treat this as an integer, we can use the int function. We just do int, we wrap the variable in parentheses. And so this will take the user's number from a string and turn it into an integer that we can then use as a normal integer. So if I go ahead and run it again, and I put in 3, notice I get 30. So now let's say we want to do the same thing with a float. We can do the same thing and turn this into a float. So I want to say 3, and I get 30.0. Right? Makes sense? We can also do it the opposite way, where we can take a float and turn it into a string. So if I do user number equals string user number, now notice when we multiply it by 10, it's going to be some really weird, it's going to be 3.0, 3.0, 3.0, so on and so forth. Because now we're treating this number as a string instead of as a float. Go ahead and write out the different types of functions used to convert between variables. So notice that we have a function for each of the different data types that we covered today, except for characters. And again, because Python, which includes characters as part of strings, just for simplicity's sake, but all the other ones have a function. Now you can use this function to convert between variable types, but please note that if you have data that is not of that variable type you're trying to convert to, you will get an error. So for instance, if I'm trying to use the int function to convert the letter A to an integer, unfortunately you'll get an error. Okay, great. So now let's go ahead and move on to our next data structure variable type, or data type. So what we're going to be talking about now is a list. And so lists are just multiple elements put together. So if we say my list, we can say, we can put in multiple different things in our list separated by a comma. So compared to when we have an integer, we only have 1. We can only set it equal to one number. With a list, we can store multiple numbers or multiple strings or multiple booleans or whatever we want. And Python doesn't really care so much about what is the data type of the variables in the list. So for instance, we can do a mix of strings and floats, integers, and it will still work out the same way. So now if I go ahead and run this again, you'll notice that I get this list here printed out. And so the way that we denote lists are by these square brackets here. Now, what's really interesting is, remember how I mentioned earlier that strings are data structure, or I consider strings data structure variable types because they're composites of characters, right? There's multiple characters as part of one string. And lists are also data structure variable types because they have multiple elements as part of a single list. And so what happens is lists and strings can actually be treated in the same way often. And so the way that we get elements from a list is by using the square bracket operator. So if we want to get the first element of the list, which is going to be this 1 right here, we're going to type in 0. So in computer science, we always start counting lists from 0. And I'm going to go ahead and print that. But also, if we want to get this first, this t here, we can use that square operator to get the first letter of our string. So if you look at it, we get 1 in t. So now, for instance, let's say we want to get 3 here in this list. take a minute, think about what number am I going to put in here. And I hope you said 2. And notice that we get 3. So this is index. I'm going to go ahead and write this out down here. So this gives you the index to access each element of the list. Now, we'll be talking a lot more about lists and what you can do with them and different slicing operations in a different video where we talk about loops. So the next thing that we're going to talk about are sets. And so sets, to denote a set, we can use these curly braces, and we'll just call this my set. And remember that sets have no duplicates. So if I enter in a bunch of numbers like this, I'm just entering random numbers, and I go ahead and do print my set, you'll notice that all of these duplicates, so 1, 3, 5, will only have one instance of them, and compared to like the 3 or 4 here of each of them here. So again, you can see that first of all, the order that we put in numbers into the set changed a little bit. So the 13 moved here, the 562 stayed there, 24 stayed there, and then 62 stayed there. But notice that we removed all the duplicates. So that goes to show you that sets themselves are not ordered, or not in the same order. Well, they're ordered in their own regard, but they're not ordered in the same way that you enter them into the program. And they also remove all the duplicates. And so that's pretty much all we really want to talk to you about sets. So then now we're going to talk about tuples. And so to denote a tuple, you can just create a new variable. We'll just use our parentheses. And so we can say 1, 2, 3. If we do print my tuple, and you print it out, notice you get 1, 2, 3. Tuples are pretty similar to lists, and the only difference is that you can't modify a tuple, but you can access certain elements of a tuple in the same way. So if we do my tuple 0, we'll get 1, right? But in a list, in a list we can do the same thing. The only difference is that we can now change my list 2 to like 700, and notice that our list changes so that we can change elements in a list where we can't do that in tuples. So now the last variable type or data structure variable type that we're going to discuss is going to be a dictionary. So to create a dictionary, we're just going to go ahead and call it my, and we're going to also use these same squiggly brackets we use for sets, but the only difference is going to be that we're going to introduce a key and a value. So now notice your key can be any other variable type that you want. So I have a string here, I have an integer here. Your value can be whatever you want. But the keys need to be unique. So you can't have 2 keys key or 2 keys 120. They have to be unique. And we can access elements of the dictionary by doing myDict and then the key itself. If we go ahead and run this, we get value. If we print out myDict, you can get the full thing right there. All right, so just as we had functions earlier to convert between the variable types, we also have functions for these variable types to convert between them. So my testing list, and we're going to say it has 7, 6, 5, 4, 3, 2, 1. Let's get rid of this. So now if we want to, let's do 2 1s. Now let's say we want to convert this list into a set. All we have to do is say my testing list equals set my testing list, and we'll go ahead and print it out. And if we print it out, notice that we get rid of those duplicates, and now we've become a set just by using this set function. So now at the same time, if we want to create a a tuple from this, we just change this to a tuple. And now we have a tuple from this list. And so that way you could convert back and forth. Let's actually just do an example. So we can do my testing list. And so notice now, after we do this, we can convert back to a list using this list operator. The dictionary function dict, but however, it's a little difficult to cast lists and sets to dictionaries just because of the nature of the data that they're stored in, right? There's not a key or a value that you can readily identify without having to do some additional, processing or something. That brings us to the end of this video.